Hello guys, today I'm going to walk you through a diagnosis of two very common codes, P0118 and P0117, circuit high and circuit low on the temperature sensors. This will apply on any thermistors like coolant temperature sensor, ambient temperature sensor, intake air temperature sensor. They're all the same, they all work on the same principle. So I'll walk you through this process. I'm going to make I'm going to create different problems that we can have in a car and how to recognize it. Essentially how this works, this sensor has two wires, this circuit has two wires, has a signal wire and a ground wire, and has two resistors, is internal resistor and external resistor. External resistor is actually temperature sensor, and the way it works, computer is going to send 5 volts through this internal resistor, through the signal wire, through this temperature sensor. It's going to also provide the ground, and as a temperature changes on the temperature sensor, it's going to change the resistance, it's going to change the current flow through this circuit, and that's going to change that's going to reflect in a voltage drop across the first resistor, and that voltage computer is going to read as a temperature. So that's how it works. Now for us, we need to know how it works, but we need to know how to recognize the problem when we have a code. So right now I have two codes on our in our power control module. We have a circuit low and circuit high, P0118 and 117. And let's go back and go to live data. Okay, just going to look at the voltage. So right now we have a 3.9 volts on our signal wire. So first checks we need to do, we're going to need a voltmeter. We're going to take the black plate, connect it to ground. I'm going to work on my coolant temperature sensor that is here. My wire on the left is my ground, wire on the right is my signal wire. Now this ground wire is shared by other sensors, which is very important. I'm going to show you, we'll see that later on in this presentation. So this ground wire is shared with other sensors like intake air temperature sensor, map sensor, TPS sensor as well. So let's go to first checks. So I'm going to put my voltmeter to DC volts, and black lead goes to ground, and my red lead, I'm going to go first to my signal wire, and we are reading 3.9 volts, which we see this on the scan tool as well. My ground side reads 2 millivolts. The 100 millivolts is maximum. It's allowed the voltage drop on the ground side, so this is a good ground. Of course, when you do this, you have to have your key on. If you need to have a scan tool. If you don't, some things can be done without scan tool as well. Let's go to the first problem. So first we're going to go through a P0118, the circuit high. In this case, we always going to have an open in our circuit, which means that our computer sees a sees a 5 volts all the time. So somewhere along this circuit we have an open. So the first will be case where we checking our ground and we're okay, and checking our signal wire and we see 5 volts. So tells you right away that everything is okay, you have an open in your sensor. So right now I'm reading 3.9 volts, but to simulate that problem, I'm just going to unplug the sensor, and so we're going to have 5 volts. That's going to be an open in our temperature sensor. So basically, you got a good ground, you got a 5 volts. The only problem that's possible is a open in our temperature sensor. So now I'm going to go to a next. So let's just do this real quick. So if we have an open in our thermistor, in our sensor, we're going to read 5 volts on our signal wire, and it's going to be 0 volts on a ground. So open in a sensor. In this case, we will change the sensor. Okay, here's the first problem. we read 5 volts on our scan tool. We're going to have a code P0118. I'm not going to go back through a scan tool to read the codes. I'm just going to waste time for it. But anyway, we see 5 volts. So what we're going to do, we're going to take the voltmeter. Black lead we're going to have on the ground again. The red lead we're going to measure a voltage on our signal wire, and we see 5 volts at the signal wire. Is same with computer, the PCM, so that's okay. We go to a ground side. On the ground side we see 5 volts as well. That's the problem. So let's put this on the board real quick. See how we can find, how we can identify what the problem is. So we have here, we have 5 volts at the computer, we have 5 volts the signal wire, and 5 volts on the ground side as well. So essentially in this we have an open again. P0118, it's an open loop somewhere. So we know there is not open in our signal wire. We don't have an open in our sensor because we see 5 volts at the signal wire, goes to the sensor, we see 5 volts again. If we have an open in a sensor we would see 0 volts, but we see 5. So what is the problem? Well, we have an open in our ground. Okay, so something else we can do, if you're not sure that that's your problem, we can take I'm going to get my lead back to signal wire, and I'm going to take a test light. I'm going to connect it to ground, and I'm going to connect it to my ground wire. Basically now I'm going to provide a ground to my sensor and see if this if this voltage is going to change. Let's see here. Having a hard time. Let's see what this does. Okay, it should be. There you go. I couldn't have a good connection. So right now what I did, I got my test light right at the connector, connected to battery ground. So basically I'm providing the ground for this sensor, and we can see our voltage went down to 3.9 volts. That's what we've seen the first time. So now for sure we know that we have an open in the ground. Okay. As I said before, we do know that this PCM shares this ground with other sensors. So we can have a problem where the PCM does not supply the ground, or we can have a problem in a signal wire. We can have an open in a signal wire. So now I'm going to take my test light, I'm going to connect the battery positive, and I'm going to check the ground on my intake air temperature sensor. Okay. So if I have a ground at my air intake temperature sensor, then my PCM is okay. I'm going to have my test light on the positive. I'm touching the ground, and you see the light is lighting. So that tells me the computer is okay. I have an open in a signal wire for sure. So that's how we address a open in the ground circuit. So what I did, this is my extra connector. So basically all I've done, I disconnected a ground here and made a open circuit on the ground side. So, but the point is to be able to recognize by doing the voltage measurements on what side of the circuit we have a problem. Alright, so let's see what we have this time. We can see 5 volts again. I'm going to take my voltmeter, still the same, the black lead is on the ground, and I'm checking my signal wire, and I see 0 volts at the signal wire. And I'm checking my ground. Of course, I'm having a 0 volts on my signal wire, on my ground. I can connect my I can still use my test light just to check the ground. It should light. So my ground is okay. So right now we have a 0 volts on my signal wire, and I have a good ground. Okay, so let's see. As I said, we can see I have 5 volts at the computer. Now we can also check that I have my this lead connected to my signal wire from the PCM, and I can take this and check that as well and see 5 volts, the same as what the scan tool is telling us. So now the signal wire, this 5 volt reference voltage, is never shared with any other thermistors. So the only problem here is an open in our signal wire. So we have 5 volts at the computer, 5 volts at the computer, 0 volts at the connector. We have an open. So what I've done, we have an open in the signal wire. So what I did, I just disconnected my my signal wire from the harness, creating a open in a signal wire. But this is the measurements we need to do, and this is how we can recognize that problem. So I'm going to provide a ground again, and we see we're going back to 3.9 volts, what it needs to be. Now, that's pretty much all you can see on this P0118. There's another possibility that could happen, that doesn't happen very often, is actually a problem with a like this connector at the power control module, or maybe the pins from the computer are rusted out. Let me see, show that. Unfortunately, I cannot duplicate that problem. I cannot create a problem to show you guys. But basically, then one of these pins here is broken. Okay, or case where female connectors on this connector at the PCM is sprung open. So you would have a 0 volts at the connector, at the signal wire, at the PCM. Of course, you're going to have a 0 volts. I'm sorry. So you're going to have 0 volts at the connector. You're going to have a 0 volts at your sensor, but you're going to actually read 5 volts on your scan tool. Okay. So if you have that case, again, I cannot create that problem here. But if you have this case, then check your connector, and if the connector is okay, check this pin, and then most likely internally this circuit is open inside the PCM. In that case, you have to change the computer. But again, that doesn't happen very often. Most of the time you have a problem on the wire itself. So that's when it comes to P0118. So let's see what could happen with the P0117. With the P0117, it's basically signal low, which means that you have a short somewhere. We can have a short inside the sensor, we can have a short on the signal wire, or we can have a internally shorted power control module. So let's see if I can create that problem. Alright, there's the first problem. We can see our signal is at 0. We're going to have P0117 signal low. Let's take the voltmeter and checking the voltage at the ground side. We see 0 volts or 4 millivolts, that's my ground, and we see a 0 volts or 5 millivolts at my signal wire, which essentially this is what we're going to have. So right now, how are we going to address this? The easiest way to do is we have to address possible shorted sensor. So we're going to unplug this sensor, unplug the connector, and if this signal wire goes back to 5 volts, I have a shorted sensor. So I'm still connected to my signal wire, and what I'm going to do, I'm going to unplug the sensor, And let's see what my voltage is going to be. There we go. And we're going to 5 volts. Going back to 5 volts. I'm having a shorted sensor. In this case, we are replacing a sensor. What I've done, I just took a little piece of wire and shorted out the sensor to simulate this problem. Of course, we can check the resistance on the sensor itself, but honestly, we don't need to do that. Checking the voltage, to me, it's a better way to do it. So that's the first problem we can have, basically shorted sensor. Alright, let's get to a next problem. Okay, we have a problem again. You can see that my signal wire is reading around 240 millivolts. So basically it's pretty much 0 volts. So now I have, let's go back to a ground. 0 volts. So let's unplug the sensor. See if you have a shorted sensor. I'm going to go back to signal wire. Unplugging the sensor. Did not change anything. I'm still at the 0 volts. So right now I have a problem, and so what we've done here, we have unplugged the sensor completely, and we are still reading 0 volts here at the signal wire. So let's check the voltage at the computer and see if we have 5 volts here. Then would be an open in a signal wire. Going at the signal wire at the computer, and we're reading 30 millivolts. Still basically 0 volts. So now the things are getting more complicated. I'm trying to figure out what the problem is. So now we oscillated the sensor. It's still reading 0 volts at the connector and 0 volts at the computer. Now we have a short somewhere at this point. Now there could be 2 problems. I can have a short to ground, or I can have a shorted computer. So what we're going to do next, we're going to unplug the connector, we're going to turn the key off, unplug the connector from the power control module, and then we're going to ohm this wire. Okay, so we're going to take the ohm meter, or we can use a Tesla, but I actually like to use ohm meter. We're going to connect this ohm meter to ground. We're going to touch this wire at the PCM right here, and only infinity is acceptable. If I have any path to ground, we're going to read some resistance on our ohm meter, and that will indicate a short to ground in a signal wire. Okay, so I'm going to turn off the turn the key off. I'm going to disconnect this harness from the computer, and I'm still connected here to my signal wire now, and I'm going to take my voltmeter, ohm meter at this point, and take the positive lead. I'm still connected to ground on my black lead, and let's check the resistance here. And we can see I'm reading 20 ohms. What do we have? We have short to ground on our signal wire. So computer is okay, but we have a signal wire problem on the signal wire, the short to ground, by reading the 20 ohms. Let's take the test light and see how that's gonna Now you can take a test light, connect the battery positive. So you can take a test light, connect the battery positive, and if there's a short to ground in our signal wire, basically we're going to complete the circuit and the test light is going to light. So let's do the same thing. I'm going to have test light on the battery positive. I'm going to touch my signal wire, and you can see it lights. So we have a short to ground on the signal wire. Okay, and basically what I did, I took a test light and connected, shorted my signal wire with my test light. So let's go back. So that will be short to ground on the signal wire. That's how we're going to address that problem. I'm going to connect this back again. Go back to a signal wire. Go to voltage. So now I'll turn the key on. And we're going back to 3.9 volts. So I did find my short to ground, took care of that. We're back to 3.9 volts. Okay, so that was a short to ground on the signal wire. There's one more problem we could have with the P0117, and I'm going to show you that, guys. Okay, so this is the last possible problem we could have on this circuit. Again, we have P0117. We can see we have a voltage on our the temperature sensor reads 0 volts. Now let's take the voltmeter. Still have my negative lead to ground. Positive lead is on my signal wire, and I'm reading 3 millivolts. Basically 0 volts on the signal wire. Let's go to ground. The same. So let's unplug the computer. Unplug the sensor to make sure we don't have a shorted sensor. Still 0 volts, no changes. Okay. Now we could have a short to ground, the same scenario we had the last time, and we're going to address that real quick. But before we do that, let's just go ahead and check our intake air temperature sensor to make sure. Let's see what kind of voltage we have there. We got 3.9 volts. I'm going to unplug it. We have 5 volts. So the computer is supplying 5 volts to our intake air temperature sensor, but as I said before, this reference voltage is not shared between thermistors. Okay, so let's do the same thing. We'll have to turn the key off, unplug the sensor, unplug the harness from the PCM. And we're going to check for short to ground again, the same way we did last time. So we're going to unplug the sensor. We have to make sure we're going to do that, because if you still keep the sensor plugged in, you're going to read resistance. Okay, alright, I'll plug the sensor. Unplug the harness from the power control module. So again, we're going to have this scenario. We're going to unplug the sensor, unplug the PCM, and let's go ahead and ohm this signal wire. Taking my red lead and I'll put on the ohms. And I'm checking my signal wire, and I have OL. No short to ground on the signal wire, but the PCM does not supply 5 volts to our sensor. Let's do a same check with our test light. touching nothing. In this case, we have shorted power control module, and it is shorted power control module, and I actually done this for this video. I do have a extra PCM. Here's the my PCM for this car, and this is from the different Sebring. But essentially, what I did, sorry guys, I shorted my 5-volt reference to ground internally, and this is what we're gonna see. This is what we're gonna see on our signal wire. So disconnect the computer, disconnect your sensor, ohm the wire, or use a test light. I still like to ohm the wire because I just like that. That's the way I like to do it. And we've seen infinity open loop, so there's signal wire. It's not shorted to ground, but the computer does not supply 5 volts. And then we check the intake air temperature sensor. We could see 5 volts there. Now checking the power and ground to the computer, I don't think it's needed. You know, I mean, I know I've done this intentionally, but since computer is supplying the 5 volts to other thermistors, having a power and ground issue, it's very unlikely. So so what I did, there's so much glue in it. So right there, I just shorted my pins, pin 20 to pin 27. Pin 20 is my 5-volt reference, and pin 27 is actually signal ground wire. So I just shorted those 2 pins to create a short to ground on my 5-volt, on my signal wire. So, and that's how we got this, where we had a 0 volts, you know, on our signal wire. I'm plugging the sensor, I'm plugging the PCM, no changes, no short to ground, bad PCM. Okay, I think this is all I wanted to show you guys. I hope this was informative. I was gonna try to make another case on an open circuit where we're gonna have actually like a bad pin that does not supply, like a computer would see. As I said, a computer would see 5 volts, but because of a broken pin or rusted pin or maybe sprung connector at the harness, we would have 0 volts in a signal wire. But then I would really completely, you know, ruin this PCM. I can still, you know, resolder this wire, be fine. So, that's it, guys. I appreciate you guys watching. I hope somebody's gonna learn something from all this, and see you next time. Thank you. Bye bye.